Hello viewers and welcome back to another video. In today's video, we are going to be showing you the functions of a keypad as an input device while displaying the letters and numbers pressed on a LCD display screen. So like, subscribe and follow along. A 4x4 keypad is made up of 4 rows and 4 columns. Using a matrix keypad can help you conserve GPIO pins on a microcontroller. For interfacing 16 keys with the microcontroller, we need 16 GPIO pins. However, by utilizing a 4x4 matrix keypad, we only need 8 GPIO pins from the microcontroller. Switches are positioned between the rows and the columns. On the screen, you're just seeing a setup of what we did. A key pressed creates a link between the specific row and column where the switch is located. Using the Arduino keypad library, the program sets all rows to 0 and columns to high using internal pull-up resistors. Such arrangements makes all columns equal to 1, 1, 1, 1 when no key has been pressed. Upon pressing the key, it establishes a connection between the row and the column. For example, if key 8 is pressed, a connection is made between row 3 and column C2. Once a key pressed is detected, the microcontroller will initiate the procedure to recognize the key. The process of identifying the key involves the microcontroller sequentially grounding each row from R1 to R4 and simultaneously reading the columns. If the data is read in all ones, no key in that row is pressed. For our case, 8 is pressed. Therefore, C2 will be low when R3 is grounded. Hence, the microcontroller identifies the key pressed. The challenge with this approach is that it makes it difficult to use the microcontrollers with limited pins, for it requires 8 digital pins. One of the options is to use the resistance-based configuration such as the one posted. We have a link for it in the description box. This has the advantage of using a single ADC channel such as A0 to A5 of Arduino Uno. The code provided matches the analog readings to resistance values and should ideally work. Challenges, however, are likely encountered in field deployment of this setup due to resistance of the keypad contact. To overcome this, as Integral, we modified the circuit to use 4 ADC channels and provide a wider range of values. The values of ADC readings were determined practically. The 4 columns were connected to Arduino Uno ADC using a voltage divider resistor arrangement. The rows were connected to VCC through resistance of different values in order to generate varying voltages for each row, hence different ADC values. The results of this arrangement were ADC values between 730 and 1000 for row 1, between 460 and 620 for row 2, between 125 and 390 for row 3, and between 25 and 80 for row 4. So if a value of 500 is detected on ADC 1, then the microcontroller interprets it as key 4 pressed. You can create your own setup by following our tutorial. Everything that we used here is available for purchase on our online store. Find the link to our store in the description box. Subscribe and see you on the next. Bye.